How's it going, everyone? In today's video, we're going to talk about descriptors in Python and what problem they actually solve. Most people encounter descriptors indirectly through things like properties, but understanding them directly removes a lot of the mystery. The key idea is simple. If an object defines certain special methods, Python lets that object control attribute access. Once you see this in action, the rest of the behavior starts to make sense. Now, before we go any further, I just want to mention that I'm using Z, the code editor, for this tutorial. If you'd like to follow along with the same editor, you can find the download link in the video description down below. Let's get started by creating the smallest possible example. So here we have a class called simpleDescriptor, which defines a dunder_get method. The arguments contain two objects. These refer to the current object and that object's class. And you can think of instance as the self object. And this is the one we will generally manipulate with descriptors. Now, when we are referencing a class, instance will be none. This usually means we're trying to access the descriptor itself, in which case we return self. Although there are some cases where you might want to do something else, but we won't discuss those today. And if we're not returning self, we're just going to return a string value. Now that we have this descriptor, we can create a class called example. And inside here, we can define a class attribute called atta, which will equal the simple descriptor. And typing descriptors can sometimes be a pain. I mean, this simple descriptor is not only going to be of type string, and that's why the code editor is giving us some syntax highlighting. So depending on the situation, I will usually have no type or the type it returns. And sometimes this type is unknowable. And in that case, it's better to leave it with no type at all. So if it becomes too complicated, you can just remove the type there. It's important to remember that type annotations are only there to help you code or to catch errors in your code. If they take too much time in the development process, there's going to be a chance that it might not be worth it. But that's something you're always going to have to determine for yourself. Although for this example, I'm going to skip on the type here. But next, I'm going to create my if name is equal to main check and create a main entry point so that we can create an instance of that example. Then we can print example.atta. And what we should get as an output is the string that we defined in the descriptor. Now, when we print the example.atta, we get the descriptor itself. Behind the scenes, this is exactly how the add property, the add class method, the add static method, and the add abstract method decorators work. Property has a method for get, set, and delete that it decorates. Class method always uses the owner. The static method uses neither, and the abstract method automatically returns a method that raises an error. But now that we understand how Python redirects attribute access, we can start using descriptors for something useful. Validation is one of the most common real-world use cases. The important thing to remember is that descriptors live on the class, but the data must live on the instance. We'll solve that by storing values under a private name. So let's implement a simple integer validator. To start this, we're going to create a class called intDescriptor. Then we're going to create the regular init block, and we're going to create an attribute called private name and set that to none. So here we have to store the value under a new name. Otherwise, we would end up with infinite recursion. This is because if we were to try and use getAtta on the name the descriptor occupies, it would in turn call the get method again. Depending on the case, you can also access the object's dunder_dictionary method instead. Anyway, below we're going to create a setNameDunder method. And here we're going to set self.private method, or private name, to the f string of _name. Then once again, we're going to define our dunder_get method. And this is going to contain self, the instance, and the owner, and return an integer. If the instance is none, we're going to do the same thing as before and return self. Otherwise, we're going to get the value under the private name. Now below the get method, we're going to create a set method, which takes self, the instance, and a value. And here we want to check whether the value is of type integer. Because when we use set, we can override what happens when we assign values. If you have ever used libraries like Pydantic, this may feel familiar. But here, what we want to do is raise a type error if the value is not of type integer. Otherwise, we're going to set the attribute to private_name. Now below we can create a class called user and use the descriptor. So here we have an age, which will equal the int descriptor. And we can do the same thing for the score. Then we'll create an initializer that takes age and score and assigns those values to the instance attributes. And now that we have that class, we can create our if name is equal to main check and our main entry point. And inside here, we're going to create a user, which equals a user with the age of 30 and a score of 100. And with this instance, we can refer to its attributes. And as soon as we run this, we should get 30 and 100 back. If at any point we try to assign a new value to age of the incorrect type, such as 30, we're going to end up with a type error that the value must be an integer. This is because any logic we write in the descriptors set method will be run on any assignment we make to the given attribute. Next, we're going to be moving on to practical patterns. So in this final section, we're going to focus on when descriptors actually make sense in production code. They are powerful, but they are also a low-level tool. One key concept is descriptor priority. Data descriptors always override instance attributes, while non-data descriptors do not. The attribute lookup order is important to understand here. When accessing an object's attribute, Python follows a strict resolution order. First, Python checks for a data descriptor on the class. If one exists, its get method is always called, even if the instance has an attribute with the same name. Next, Python checks the instance dictionary. And finally, Python checks for a non-data descriptor on the class, because non-data descriptors define only get methods, and they can be overridden by instance attributes and effectively act as defaults. This small difference is what gives data descriptors their authority. Understanding this helps avoid very subtle bugs. Let's take a look at a concrete example. So here we're going to create a class called non-data descriptor. And as always, we're going to define a get method, which takes self, the instance, and an owner. And all we're going to do inside here is return this string. Because this class does not define a set method, it is considered a non-data descriptor. This means Python assumes that it's okay for this to be overridden by values in the object's dictionary. This is useful when you want to do things like provide defaults. And this is actually how the data class's field works, allowing the dictionary values to override the descriptor. Now below we can create a data descriptor with the same get method which has the same signature. And this is going to return a string. Now, if a set method is defined, then the get method is always called, as it assumes it is transforming or controlling data. This is how the property decorator works. It overrides the get, set, and delete methods. So right below, what we're going to do is create a set method. And inside here, all we're going to do is pass. If we do not define a set method, nothing will happen, and the above value will always be returned regardless of if something else is assigned. Now to show you how this works, we're going to create a class called example, which uses the non-data descriptor and the regular data descriptor. And in this example, we're going to create two instance attributes, one called non-data and one called data, and assign them both a new value. Then as always, we can create our if name is equal to main check and our main entry point, so that we can create an instance of example and print the attributes example non-data and example data. So the non-data descriptor will always be overridden. The data descriptor, on the other hand, will not. So when we run this, what you should notice as an output is that the first one grabbed the instance value, while the second one still holds the value from the descriptor. So that's the difference between these two. Now for some common questions. When should you use descriptors and when should you use properties? If you are defining a particular value only once, then use a property decorator. Otherwise, if you have lots of similar defined properties, you can design a descriptor. Other use cases for descriptors is lazy initialization, caching, or even facades to hide file access. It's an incredibly useful and powerful tool when used correctly, but can lead to unexpected and surprising behavior if misused. Now, when should you use a data descriptor versus a non-data descriptor? Well, non-data descriptors are used when you want to provide some default, whether it's lazy evaluated or some other kind of value when an object is created. You could, for an example, make a default descriptor. that works like the data class field descriptor. But for this case, it will work for any class. And you should use the data descriptor when you intend to manipulate incoming or outgoing attributes. This could include things such as reading and writing data from a database, validating values, and calculating dynamic properties. Anyway, that just about covers everything I wanted to discuss in today's video. Do let me know in the comment section down below whether you have any more comments or questions regarding descriptors, or if you want more videos on descriptors. Otherwise, with all that being said, as always, thanks for watching, and I'll see you in the next video.